Make sure my mic is on. All right, we good to go now. Yeah, we good to go. All right, so let me see your question real quick. So we just like reviewing some homework questions right now. Yeah. Oh, this always happens to me. All right, so 6y plus 14 over y squared minus 4 times y plus 2 over 3y squared plus 7y. All right, appreciate you. All right, so what we want to do here, right? This is multiplying, right? The rational expressions. I want to factor each one of these, right? I want to factor each one of these, the top and the bottom. Hold on one second, projector acting up. All right, good. All right, so I'm gonna start off with the 6y plus 14, right? What's the greatest common factor there? 2, right? Right, so I'm gonna factor out of 2, and what am I left with? Y, 3y, you're right. 3y plus 7, that's excellent, right? Now I'm looking right below it, the y squared minus 4, right? Y plus 2, y minus 2, excellent, times. Now I'm gonna use a dot multiplication for this. This is gonna be y plus 2, right? And now I'm looking at the second bottom. So this is a 3y squared plus 7y. What's the greatest common factor there? Y. No. What's the greatest common factor? For the 3y squared plus 7y. Y. Y, right? So I'm gonna factor out a y. And what does that leave back? 3y plus 7. Very good. Just like that, right? So now that I got everything factored, I could cross out my like terms, right? Remember, we could cross out vertically up and down, or we could cross out diagonally, right? So 3y plus 7 is the same as 3y plus 7. Y plus 2 is the same as y plus 2, just like that. And then right after that, just multiply straight across. So what do we have? This is right 2 over here over the y times the y minus 2, and that's it. Okay. Then you just put that in, and then you're good to go. I noticed that in web work now they have like this I don't even know what it's called, like matte prints, or like this pretty feature where it looks like an actual fraction. Before it would just look like code almost, you know? Yeah. You got a question? All right, give me 1 second. Hold on. Oh, yeah. Wait, hold on 1 second. Hold on 1 second. Trying to get this thing. I don't want this interrupting us. All right, we're good to go now. Sorry about that. All right, let me just switch my pen up real quick. So I got x to the second power, okay? Negative 3xy. Okay, like that? Uh-huh. Negative 10y. All right. That's it? All right, and then they just want us to factor it, right? All right, cool. So right off the bat, we know that our factor is gonna look something like this, right? Gonna have 2 parentheses, gonna be in there. So the only way to get x squared, all right, is to have x times x right here. So that part is done, right? Let's get to the next part. I have a negative 10y squared. Now, you know, the only way that I can get a negative number from multiplication is if one of them is positive and one of them is negative, right? So that means it's going to be a plus here and a minus here. If you want to do it in reverse and put the minus there first and a plus, that's fine. I don't care, all right? Next, I need two numbers that multiply to give me 10. Lucky for us, right? There's only two, right? It's 2 and 5, right? But now, how do I know which place to put them in, right? I'm gonna look at the B term right here, the B term, right? So I noticed that the B term here is negative. That means that the larger number has to be negative. So which one's larger between 2 and 5? It's the 5, right? So the 5 goes here, and the 2 is gonna go here. But notice this thing got a second variable though, right? You got that y squared. And how do you get a y squared? You got to put the y here and the y here. And that's it.
So look what I did.
All right.
Find out when to do this and when exactly to do this.
The AC method?
Mm-hmm.
AC method all the time.
All the time.
Yeah,
So
but
then-
that's only when you're dealing with, like, that's only gonna be the numbers. When you have like two variables, it's gonna be a variable here and a variable here. Like that. It'll never be like this. It'll be split. Yeah. And that's it. That's how I think about it. Go ahead. Go ahead. Say it again, I'm sorry.
2x squared
Okay.
is 9x plus 10. This is fine.
That's it. Just factor it.
Yeah.
All right. So this is like straight AC method right here. All right. So A times C is going to give me 2 times 10, which is equal to 20, right?
Yeah. Negative 5 plus negative 4.
I like that. So negative 5 times what? Negative 4?
Yeah.
Okay, I like that. That's 20. And negative 5 plus negative 4, that's negative 9. That's excellent. So now what you want to do after this, you want to rewrite the question that you have. So we're going to start off with the 2x squared. But instead of the negative 9x, I want to do the numbers that we found. So this is negative 5x, right? Minus 4x plus 10, right? Then after I get that, I want to group these two together, right? So I'm gonna have a left-hand group and a right-hand group, right? On my left-hand group, that's the 2x squared minus 5x. What's the greatest common factor there? X, right? So I'm gonna factor out of x here. And what's left over? Excellent, minus 5, right? Now I'm looking at the right-hand group. That's the negative 4x plus 10. What's the greatest common factor there? Close. Negative 2, right? And the reason why it's negative because the sign of my leading term is going to be the sign of my factor always, right? So I have negative 2. Remember, it's like you're dividing by negative 2, like you're dividing by negative 2, right? So what's left over? 2x.
Plus negative
Okay, I'll take it. Minus 5, right? Greatest common factor one more time, right? They have a 2x minus 5 in common. I'm going to factor that out. And then what's left over? The x minus 2. And then that's it.
Let me take a picture of this.
Sure. No problem. Yeah. Yeah. Go ahead. Mm-hmm. Just like that? That's not so bad. So look, start off A times C, right? You already know that's gonna be what? 4 times 1, which is 4. And my B is equal to 5. So I need two numbers that when I multiply them together will give me 4, but when I add them together will give me 5. What are they? Not 5 and 1. No. 4 and 1, right? So 4 times 1 is 4, and 4 plus 1 is 5, right? So you already know what I'm gonna do, right? I have 4x squared up here, right? But instead of writing the 5xy, right, I'm gonna have plus 4xy plus xy plus y squared, just like that, right? And then what do you want to do? I want to group these together, right? So I have a left-hand group and a right-hand group. On my left-hand group, that's the 4x squared plus 4xy. What's the greatest common factor there? For what? 4x, right? So I'm going to factor out the 4x. So what does that leave behind? Remember, it's like you're dividing by 4, it's like you're dividing by 4x. What's left over? Nope. X. X what? Plus what? Plus y, right? Good. All right, I'm looking at the second group. That's the xy plus y squared. What's the greatest common factor there? Y, right? So that's gonna be a plus y. So what's left over? Man, it's like you're dividing by y. Like you're dividing by y. God bless you. What's left? X plus y, right? Now, greatest common factor one more time, right? I'm gonna factor out that x plus y. And what am I left with? I'm left with 4x plus y. And then that's it. Yeah. X squared minus 1.
Over X squared plus 5x.
X squared plus 5x plus 4. Okay.
Times.
Uh-huh.
X squared plus
Okay.
over X squared minus 2x plus 1.
All right. So all you got to do here, just factor each one individually, right? So for the numerator here, what's the factor?
X plus 4.
X what?
Plus 4.
No. X minus 1, X plus 1. What about the bottom? What's that going to be? Uh-huh. Two numbers that multiply to 4 but add up to 5. All right, so plus 4 plus 1 times. What about the numerator for the other one? Okay, I'll give you that, x and x. I need two numbers that multiply to -3 and add up to +2. 3 and 1. What's the signs? Plus 1. No. No. No, not 2. Plus 3. Uh-huh. What else?
Minus 1.
1, right? Because 3 plus -1 is +2. And 3 times -1 is -3. All right, what about the bottom? Uh-huh. So two numbers that multiply to +1 but add up to -2. What are they?
Plus 1 negative
No.
-1 plus 5.
No. -1, -1.
Oh.
All right. Because -1 times -1 is +1, and -1 plus -1 is -2. All right. After you have that, cross out the like terms. I have x minus 1, x minus 1, x minus 1, x minus 1, and that's it. Can't do nothing else. Oh, shoot. I'm blind. X plus 1, x plus 1, right? So that's it, right? We just have x plus 3 over x plus 4. And that's it. All right, let's jump into today's lesson, because we need some time for this one. This is gonna be a goodie, promise. We're going back to basics over here. All right. But first off, I need y'all to help me out a little bit though, right? A little blast from the past. So how do I do this again? This is 7 over 10 plus 8 over 15. I want to add these together. LCD, right? What is the LCD here? Yeah, what is it? Not 5. Remember, 10 and 15 has to go into it. Not cross multiply. No. That's what that's when you have the equal sign. It's 30, right? LCD here is 30. Right? Remember how we do that? The 10 is 2 times 5, right? And the 15 is 3 times 5. Right? Remember how to do that?
Let's get very, so five,
So I take one of them, right? It doesn't matter which one. You could take the 10, you could take the 15. I'm gonna take the 10 just because it's on top, right? So for LCD, right? I'm taking the 2 times 5, right? And then I look at the next number that I have there, right? I already have 1 5, but I'm missing the 3. I'm missing the 3, so I'll multiply this by 3 right here, and that's how you get the 30. All right? I don't know if y'all remember that from like the second day or something, right? So anyway, if the LCD is 30, how do I change a 10 into 30? Multiply by 3, right? So I'll multiply this by 3, but what I do to the bottom, I gotta do to the top, right? How about 15? How do I change a 15 into 30? Multiply this by 2, right? But what I do to the bottom, I gotta do to the top, right? So what do I have now? Right? We have 21 over 30 plus 16 over 30. Excellent. Add them. And what do we get? 37 over 30. That's it. All right? Little blast from the past. Just to make me feel good. What about subtraction? How we do that again? Same thing, right? What's the LCD here? Hmm? 36, okay. How do I change the 4 to a 36? Exactly, right? Oh, but what I do to the bottom, I gotta do to the top, right? What about the 9? How I change that into 36? By 4, right? What I do to the bottom, I gotta do to the top. All right? So we multiplying these out. 3x times 9. What is that? That's like 27x. All right, over 36 minus 8 times 4. What's that? 32, right? Over 36, right? Put that all together, right? What we have? We have 27x minus 32 all over, what's this thing called? 36, right? Bam. Yeah, we good to go. Yeah. I mean, if there was a common factor in the top, then I'd ask you to like pull that out, cross it out, blah, 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 but there's no common factor there. All right, all right, all right. Even though we just did this just to make me feel good, I do this. Exactly, right? I'm gonna switch this up. I'm gonna go purple for this. I'm gonna distribute this, right? And distribute this. Uh-huh. And then we're gonna combine like terms, right? Remember this? Distribute and combine like terms. 6 times 2x, what's that? 12x. 6 times 1 plus 6. Negative 4 times x is negative 4x. Negative 4 times negative 5 is, what's that? Positive 20. Excellent, right? Now we want to combine like terms, right? Which is a really fancy way of just saying add, right? So 12x minus 4x is 8x. And 6 plus 20 is, what's that? Plus 26. Excellent. And that's it. Good to go. All right. Not bad, not bad, not bad. So let's get into this. So it is the same with rational expressions, right? So to add rational expressions, they must have a common denominator. When the denominators are the same, you add the numerators and place the sum over the common denominator. That's it. So big shock, we're doing the same thing all over again, right? Nothing confusing here. So rational expression, addition, and subtraction, that's what we're getting into. So if P, Q, and R are polynomials, where R cannot equal 0, then P over R plus Q over R is equal to P plus Q over R. And P over R minus Q over R is equal to P minus Q over R. Same thing that we did before. Only thing is that instead of numbers, we now have polynomials. Let's take a look. So to add or subtract rational expressions with a common denominator, add or subtract the numerator and place the result over the common denominator. We always simplify rational expressions. Be sure to factor if possible after you subtract the numerators so that you can identify any common factors. Remember too, we do not allow values that would make the denominator 0. What value of x should be excluded in the next example, right? So some of you might have seen that in the homework, right? Where they're asking for excluded values. You just take the denominator, set it equal to 0, and then that's it. All right? So let's take a look at this. I want to add 11x plus 28 over x plus 4 plus x squared over x plus 4, all right? They both have the same denominator, right? So all we have to do is just add the numerators. That's it, right? So 11x plus 28 plus x squared is going to come out to x squared plus 11x plus 28, all divided by x plus 4. That's simple, right? After that, factor the top, cross out like terms if possible. That's it. So let's factor the top of this. Give me two numbers that multiply to 28, and when I add them together, will give me 11. What are they? It's gonna be x here and x here. Seven and 4, I like that, right? So plus 7 and plus 4, right? All of that is over what? X plus 4. So when we cross out the like terms, what am I left with? Right? Final answer is just the x plus 7, right?
So you added the numerators?
Yep, just add the numerators, and after I factored it, I had a common factor. So that was it. Right? Let me ask you something though, right? Looking at this polynomial right here, right? What would be my excluded value? What value of x is not allowed in this conversation? Not x squared. Remember, I don't want the denominator to be 0. So what number would make the denominator 0 for x? Not 0. All right, in a complicated way, I'm asking you, what is x plus 4 equal to 0? Negative 4, right? Subtract 4, subtract 4. So x is equal to negative 4, right? This is your excluded value. All right. Sometimes in the homework, they're going to ask you for that as well. All right.
Yeah.
They do ask you for that, right? So basically, when they're asking you about excluded value, the denominator cannot be equal to 0. That's illegal, right? So set the denominator equal to 0, and then when they say what is the excluded value, you just tell them it's this number right here, and that's it. Right? X equals negative 4, yeah. That's the excluded value, but the answer to the overall question is the x plus 7. Okay. All right, that being said, You guys try. Remember, just add the fractions, factor them, cross out the like term, right? Give me the answer and tell me if it's what the excluded value is.
How do you get,
Exclude by set the denominator equal to 0. And then just solve for x. What that's telling you is that x in this problem right here, this expression, could be any value except whatever value would make that denominator 0. I don't know what it is about today, just everything just logged out on me. Every single, yeah, yeah, it was like an outage or something, you know.
Has to be, what, adds up to.
Add up to 9 and multiply to 14. Yeah. Okie dokie. Yeah. Okay, let's take a look at that. So first, I'm gonna add them together. X squared plus 9x plus 14 is all divided by x plus 7. And then we're gonna factor this, and you said you had x plus 2 and what else? And x plus 7. Okay, I like that. 2 times 7 is 14. 2 plus 7 is 9. That's excellent. And all of that is over x plus 7. I'm gonna cross out the like terms like so. So what am I left with? X plus 2. That's my answer. And then excluded, x equals -7. Right? And how you get that? You just solve, you take the denominator, set it equal to 0, right? Boom. Subtract 7, x equals 7, and then that's how you get that. Questions on this, anybody?
I have a question.
Go ahead.
It's like,
Huh?
I have a question. It's like x squared minus x minus two over x plus one. Then when the two value in that,
So the denominator of that over the x plus 1 equals 0. Just solve for x. All right. And that's it.
over that.
X plus 1 equals 0. Just solve for x. Yeah. Back to the top and the bottom, and then cross out the like terms. Let's try a little subtraction real quick. All right. So I got 5x minus 7x plus 3 over x squared minus 3x minus 18 minus 4x squared plus x minus 9 over x squared minus 3x minus 18. Now, I notice just from looking at this that I have the same denominator, right? So if I have the same denominator, all I have to do is subtract the numerator, right? And we remember how to subtract polynomials, right? What do I do? First, I need a pen. All right, what do I do? How do I subtract polynomials
Um,
before that? Like I want to subtract the numerators, so how do I subtract polynomials? The numerators are different, the denominators are the same.
no,
You don't remember? Not multiply. I want to subtract them, so what do I do? Also, like you just put another polynomial there and subtract it, like how we did in division. Uh-huh. Okay. So you're suggesting that I should just do minus and then 4x squared plus x minus 9 like that?
Yep.
Okay. We can do it that way too. What I was hoping that somebody was gonna say was I'm gonna distribute the negative and then just combine the like terms. But okay, we could do it straight as well, right? 5x squared minus 4x squared is what? Good, 1x squared. Negative 7x minus x is what? What's the sign? Negative what? No, negative 8x, right? And then 3 minus negative 9 is what? No, no. 12. That's 12. Right? So then that's my numerator right there. So that's my numerator. I have x squared minus 8x plus 12, all divided by x squared minus 3x minus 18. Very simply, factor the top, factor the bottom, go ahead. I didn't add them, I subtracted, no? So look, 5 minus 4, 1. Negative 7 minus 1, negative 8. 3 minus negative 9, positive 12. It means this, in case you're wondering. It's that, which becomes 3 plus 9. Remember, negative negative is positive? That's what it is. Yeah. Which one? Oh, the straight way? So the straight way that I wanted to do it, right? Let me just do that in a different color real quick. The way that I wanted to do it was I wanted you to subtract. I wanted you to just distribute the negative, right? Yeah. And then you just combine the like terms. So I have 5x squared minus 7x plus 3, right? And then minus 4x squared minus x plus 9. I ran out of space here. Hold on one second. Minus x plus 9, right? And then you just combine like terms. So just add, right? 5x squared plus negative 4x squared. That's just the regular x squared. Cross these out. Negative 7x plus negative x is negative 8x. Cross these out. And then 3 plus 9, that's the 12. Either way works. If you want to do it vertical, go ahead. If you want to do it this way, go ahead, right? But when you get down to this point right here, I have x squared minus 8x plus 12 over the denominator, which is x squared minus 3x minus 18. Let's factor that, all right? So what's the numerator? Tell me. Okay, I heard x and x. I need two numbers that multiply to positive 12 and add up to negative 8. What are they?
Yeah, that's from 4 and 3.
4 and 3?
Wow.
Well, 4 plus 3 is 7. 6 and 2, right? What's the signs? I hear you on the negative 6. Negative, negative, right? How'd you know that? That's good.
I just guess because the middle term is negative, the end term is positive.
Right. So when the n term is positive, right, that means that the only way to get a positive number through multiplication is if both numbers are positive or both numbers are negative. But because the b is negative, both of these have to be negative as well. But what about the bottom though? Let's use that same logic, right? I have x and x, right? My c term here, my last term is negative 18, right? It's negative. So what does that mean? That means that one number has to be positive, one number has to be negative, right? Now I need two numbers that multiply to negative 18, and when I add them, add up to negative 3. What are they? Close. Positive 3, negative 6. Now, how did I know that, right? I look at the b term, right? The b term here is negative, so the larger number has to be negative. Just like that, right? Again, this is confusing. AC method, right? I'm using shortcuts because I'm like restricted on time when teaching, right? But you guys know the AC method, it always works, it never fail you, right? It works for every single question, right? At this point now, I want to cross out the like terms. What are my like terms here? X minus 6 and x minus 6. So what am I left with? I have open parenthesis, right? Over x plus 3, right? All right, so that's my answer. They might ask you what the excluded value is, right? So what would my excluded value be up in here? So I heard negative 3. And there's another excluded value here. No. No. So here's what I'm looking at when I'm thinking about it, right? I'm looking right here. You have that x plus 3 and that x minus 6. 6. That's it. Those are my excluded values. Right? So you set the x plus 3 and x minus 6 equal to 0. Solve for x in both. You're gonna have two excluded values here, negative 3 and 6. So x can be any value it wants to be except those two values right there, negative 3 and 6. That's it. Sound good? All right. You guys try.
Wait,
You can. If it was me, that's the way I would do it. But if you wanna do it vertical, you have my blessing. Go ahead. So,
back to the bottom part too.
mhm. Top and bottom, and then whatever's left over, that's your answer. Now just give me the excluded values. Hmm? So set these equal to 0 to solve for this. So then now just give me the excluded values. So set the denominator equal to 0. All right, so let's take a look. Let's take a look, right? So if it was me, it's just my preference. I like to distribute my negative and then combine like terms. If you want to do it vertical, go right ahead. Don't let me stop you. All right, it's just my preference. So I have 4x squared minus 11x plus 8 minus 3x squared minus x plus 3. All right. And of course, all of that is over the same denominator, x squared minus 3x plus 2. Right after that, I just want to combine like terms, right? Combine like terms. So I have a 4x squared plus a negative 3x squared. That's going to give me a 1x squared, right? Cross them out because I'm done with that. I have a negative 11x minus x, which is what? Nope. Negative 12x, right? I'll cross that out because I'm done with that. Now I have an 8 plus 3, which is what? 11 or 12? One of them, 11 sounds more like it, right? Over x squared minus 3x plus 2, all right? Y'all got to give me them right additions. Y'all know I still count my fingers, all right? Y'all can't see me, but I'm doing it, all right? So now we got to factor our numerator and factor our denominator, all right? Whew, this is hard. I need two numbers that multiply to positive 11 but add up to negative 12. What are they? Right? Negative 11, negative 1. Now on the bottom, I need two numbers that multiply to positive 2 but add up to negative 3. What are they? Right? X minus 2,
That's
X
great. I
minus
couldn't
1.
get that the whole time I was stuck there.
It's good, it's good. Then cross out our like terms, right? So look, now we have x minus 11 over x minus 2. That's my answer right there, right? Bam. But you know, on your homework, they're probably gonna ask you like, oh, what's the excluded value, right? So for the excluded value, what we gonna do? We're gonna set the denominator, right? Which is the x minus 2 and the x minus one, we're gonna set that equal to 0, solve both of them for 0, right? I mean, for x, excuse me.
We
So
got-
x,
we got-
for which one? For which,
we got-
this is the factor of the denominator.
Oh,
Yeah. Right, so x minus 2, x minus 1 equals 0, solve for x. I'm gonna add 2 over here, add 2. Right, gonna add 1 over here, add 1. So what do I have? I have, oh shoot, hold on one second. Stupid pop-up. All right, let me try it again. I have x is positive 2 and 1, right? And these are my excluded values. Go ahead.
you got that one.
The 1 is x minus 1, right?
X minus one.
No, it's denominator, bottom numbers. Right? I'm actually just looking right here, to be honest with you. Right, and I'm setting that equal to 0. Calling it a day.
answer is not X minus one.
That is the answer. X minus 11 over x minus 2. But on the homework, they might ask you what's the excluded values. Right? So this right here that we just found, that's the excluded values when you set the denominator equal to 0.
Got it.
Yeah.
So then there's
Yeah.
two types of.
It's like two type of answers. And what the excluded value means is that in this particular expression, x could be any number it wants to be, except these two, except 1 and 2. Right? All right. So let's take it up a notch, right? So we want to add and subtract rational expressions whose denominators are opposites. All right, let's take a look at this. When the denominators of two rational expressions are opposites, it is easy to get a common denominator. We just have to multiply one of the fractions by -1 over -1. Let's see how this works. Let's say I have 7 over d plus 5 over -d, right? If I multiply the second fraction by -1 over -1, which is gonna make what? It's gonna be 7 over d plus -1 times 5, exactly, right? So now when the d is positive on the denominator, they're both the same thing, so now I can just work with the numerator, right? So 7 plus -5, we know that's gonna be 2, so final answer, 2 over d. And it's just that simple, right? When it's opposite, just multiply by -1 over -1, and then it's gonna change around, and then you can just go ahead and work it the way that you normally know how to. All right, like check this out, Whoops, hold on, hit the wrong thing, 1 second. Hit the wrong button, my fault. Here we go. So I have m squared minus 6m over m squared minus 1 minus 3m plus 2 over 1 minus m squared. Now you see if that 1 minus m squared was m squared minus 1, all I'd have to do is work with the numerator. So in order to make it like that, what I'm going to do, I'm going to multiply the denominator by -1 and the numerator by -1. Right? If you multiply it by the same thing, you're not changing the question. You're just changing the appearance of the denominator. Right? And then bam. So what do I have now? I have m squared minus 6m over m squared minus 1. Let's say I'm going to distribute this. Boom, boom, right? Minus, what do I have now? I have -3m minus 2 all over the m squared minus 1. Right? Just distribute it. That's it. Yeah, it is. M squared is positive now, and then the 1 is negative now. Right? So now that I have the same denominator, light work, right? You already know what's gonna happen. Right? I'm gonna distribute this. I'm just doing it my favorite way. If you want to do it vertically, you have my blessing, go right ahead. So look, I got m squared minus 6m A negative times a negative is a, what's that, positive 3m? And a negative times a negative is a positive 2, all divided by same denominator, m squared minus 1. Let's combine like terms. Combine like terms. So I have m squared, negative 6 plus 3, what's that again? Negative 3m, good. Plus 2, all divided by m squared minus 1. All right, let's factor this real quick, right? So I have a m squared minus 3m plus 2. Help me out. This is m and m. I need two numbers that multiply to positive 2 and add up to negative 3. What are they?
So,
Negative 2 and negative 1. Very good. All right, here's a harder one, right? I have m squared minus 1, right? We know it's going to look like this. What's the factor of m squared minus 1? mm, good. Not 1 over 2. Negative 1, I heard that. And what's the other one? Positive 1. The difference of two perfect squares, right? One negative, one positive. That's it. After that, you already know, cross out the like terms, bop, bop. So final answer, m minus 2 over m plus 1. Boom. If we were going to do an excluded value, you already know. This is going to be m is equal to what two numbers? Set the denominator equal to 0. What would be my excluded values here? 1 and negative 1. That's it. All right. Any questions on that? Anybody? Make sense? All right. So that's our trick. Just multiply by negative 1 over negative 1. You guys try. Sure.
The question I have, for example, if we have a replacement for most for negative one, so it's okay because here negative one times we want it to this solution.
Right.
For here, for example, here, that is negative m squared.
Mhm.
If we use the same reciprocal property,
Right,
it's
right, right.
supposed to be positive. So
It
what-
is. Yeah, because see, look, it becomes positive right here. The next line.
in the next line,
Yeah, right here. See how this is positive m squared and negative 1?
oh,
Right.
yeah, I get it.
And then she, yeah. Hmm? Like up here. Mhm. Two of them, negative 1 over negative 1. Yep, this is the trick. Yeah, y squared minus y. Looks good. Factor, cross out like terms. So basically, like, this is all that's gonna be like test two, just doing factoring. Are we doing this? Say again?
Addition, subtraction, addition.
Right, that's it. Yeah,
And rational. That's it.
yeah,
For that one, we have.
yeah. It's not bad.
It's gonna be like back to back.
Yeah,
We only got-
yeah. It'll be quick. It's not bad.
We got one month left.
Yeah. August 1st. Oh,
Fine.
the final, yeah. But we got a lot of time to prepare and all of that. Good. I feel like this next test is probably gonna be like the easiest one. It's only like two chapters, but or like two topics, factoring and rational expressions. Low-key, I don't even know if I should even ask you any factoring questions. I'll probably just ask you some rational expressions and call it a day. Yeah. Like that's what I did on the first test. Like, why am I gonna ask you what 2 + 2 is when we got fractions and all that that involves that? But I'm gonna hook y'all up with a review sheet, probably Thursday. Thursday, no. What's that day before Thursday? Wednesday? Yeah, that day. Yeah.
Test is on Monday.
On either Monday or Tuesday. I'm still deciding. You know? Yeah. Y'all want Tuesday? All right. All right.
Monday, is that the-
All right. I mean, but Monday is gonna be like a new topic though, still, you know? Yeah. Yeah. All right,
My birthday, so I could like go to the earning, get that.
got you. All right.
And we're gonna say two.
I mean, it's whatever y'all want. Y'all want a Monday, cool. Y'all want a Tuesday.
Sorry, so then- Nah,
You want to hold out that long though? Because it's gonna be like mad material we're gonna learn in that time.
that's the thing.
Yeah, like the week after. Yeah, yeah. That's what I try to do every 2 weeks. An exam. Yeah, not too bad.
Me take one day. Get that over with.
I mean, we could all take it Monday. I'm giving y'all the review sheet on Wednesday. Y'all gonna be ready for it. Y'all got all the homework. It's only a couple of sections, not even that many. Right? And it's all the same thing. I probably won't even ask you anything from chapter 6. It might just be this, and that's it. You know? But we gotta do some complex stuff also. That's gonna be fun. Wait till y'all see that. All right, so look, first thing I want to do, I want to multiply this by -1. -1, right? Numerator and denominator. So what do I have now? I still got the y squared minus 5y. That's a 5, by the way. Over the y squared minus 4, right? Keep that minus, distribute this negative, pop, pop. So what do I have? -6y. Hold up, I forgot how to draw y. right? And then positive 6 all over y squared minus 4, right? Boom, right? Because we just distribute that. Not too bad, right? We have the same denominators now, so now I can subtract. Y'all know how I like to subtract, right? Mm-hmm.
Why does it say
Why does what stay negative?
for,
Wait, say it again? Hold on. Which part?
we got 4 and negative?
Oh, you mean like you talking about the denominator, right? All right, so I'm distributing the negative 1 here. So negative 1 times 4, right? That's negative 4, right? So negative 4. And then negative 1 times negative y squared, that's positive y squared, so positive y squared, like that. Yeah.
Oh, just flip the sign and then you rearrange it the way you want it.
Exactly, yeah. Because the whole goal is I need the same denominator so that I could legally just work with the numerator, you know? So after that, you already know what I'm gonna do next. I'm gonna distribute this negative, that's just my preference. You do it the other way if you want. So what do I have now? I have y squared minus 5y. A negative times a negative is a positive, 6y. And a negative times a positive is a negative, 6. All divided by y squared minus 4. Let's combine like terms here. What do I have? I have y squared plus y minus 6, all divided by y squared minus 4, right? Let's factor this, right? I want to factor the top, factor the bottom. Let's pull this to the side over here, right? Factor the top, factor the bottom. So y squared plus y minus 6. I need two numbers that multiply to negative 6 and add up to positive 1. What are they? Multiply to negative 6 and add up to positive 1.
One.
There's y minus 3, y plus.
Okay, which one is negative, which one's positive? 3 is positive and 2 is negative. Good. All right. What about the bottom? What's that? Very good. Y plus 2, y minus what? Minus 2, very good, right? Cross out the like terms, right? Final answer, over y plus 2, very good. And that's it, right? Excluded values, what's that?
2, negative 2 and 5.
Very good. Boom, boom, boom. Questions on that? Just separate them by a comma in web word. That's it. All right. So let's really get into this topic. That was our warm up. All right. So here we want to find the LCD of rational expressions. All right. It's the real meat and potatoes right now. So when we add or subtract rational expressions with unlike denominators, we will need to get common denominators. If we review the procedure we use with numerical fractions, we will know what to do with the rational expressions. It's the same thing, people. Same thing, right? Let's look at this example. 7 over 12 plus 5 over 18. Since the denominators are not the same, the first step was to find the least common denominator, LCD. To find the LCD of the fraction, we factored the 12 and the 18 into primes, lining up any common primes in columns. Then we brought down one prime from each column. Finally, we multiplied the factors to find the LCD, right? So when we add numerical fractions, once we found the LCD, we rewrote each fraction as an equivalent fraction with the LCD by multiplying the numerator and denominator by the same number. We are now ready to add, right? So we have the 7/12 plus the 5/18. We factored it, found the LCD to be 36, right? We multiplied by whatever number would make the denominator 36. But what you do to the bottom, you gotta do to the top, right? What you do to the bottom, you gotta do to the top. And then boom, now we have 21/36 plus 10/36. Add those up, and we get what? 31/36. And that's it. That's it. So real quick, just to make me feel good, right? This is the procedure. I want y'all to have that. So how to find the least common denominator of rational expressions. Step 1, factor each denominator completely. That's step 1. Step 2, list the factors of each denominator. Match the factors vertically when possible. Step 3, bring down the columns to include all the factors, but do not include common factors twice, right? And step 4, write the LCD as a product of the factors, all right? Let's take a look at this. And try and leave a little bit of the instructions up. Whoops. Heard that. So here, we want to find the LCD for this expression, right? Not adding or subtracting yet, we're just finding an LCD, right? And then B, we want to rewrite the equivalent rational expressions with the lowest common denominator. So let's look at this. I have 8 over x squared minus 2x minus 3. And I have 3x, comma here, over x squared plus 4x plus 3, right? First thing I want to do is I want to factor the denominators, right? So I'm going to factor these. So I'm going to have 8 over, what's this? X minus 3, x plus 1, something like that. Again, AC method if you are not sure how I did that, right? Over here we have 3x over, what's this? X plus 3, x plus 1, right? Two numbers that multiply to positive 3. When you add them together, get 4, boom, right? Now, I want to find the LCD, right? Not doing any math here yet, not adding, not subtracting, just trying to find the LCD, right? And the LCD is as follows, right? Take one of them. It doesn't matter which one. I'm going to take the first one just because it's the first one over here, right? I have x minus 3 and I have x plus 1, right? Now I'm going to look at the second denominator, which is x plus 3 and x plus 1, right? I already have an x plus 1, but I don't have an x plus 3, so I'm going to multiply this by x plus 3. That's it. That's the LCD. That's simple. Huh? All right, so look, what I do, right? I take one of them, right? I just happen to choose this one because that's the first one. No particular reason, right? And I write that down here, right, for the LCD. And then I look at the second fraction, right? This is the second fraction over here. And I realize I already have an x plus 1. That's a common factor, right? But I don't have x plus 3. So that's why I add that down here. Exactly. And just put them next to each other, multiply them, boom, that's the LCD. All right? It's that simple. The vertical way that they're talking about doing it, right, is they would have you do x minus 3, x plus 1, and then x plus 3, x plus 1. And it's the same like kind of logic as what I just described, right? So these are different, right? So they would write these down. X minus 3, x plus 3. And because the x plus 1 is common, you'd only write one of them down. So that's the vertical way of doing it. Okay? Whichever is easiest for you, it don't matter. All right, whichever is the easiest way for you.
So you had
Mhm.
that orders the three.
No particular reason, just did it like that. Part B says what? Rewrite the equivalent rational expressions with the lowest common denominator. So that's 8, right? I'm gonna change the color for this. I'm gonna do this in orange. Sure. Not quite done yet, though. I'm gonna do part B now. So look, for part B, they want us to write it as an equivalent fraction, right? So originally, we had what? We had 8 over x minus 3, x plus 1. Well, we know that the LCD has an x plus 3, so I'm gonna multiply this by x plus 3, but what I do to the bottom, I gotta do to the top, right? So do the math on that. What do you have, right? Distribute, all that good stuff. This is 8x plus 3. I'm just gonna leave the denominator like this because it's just easier. X plus 1, x plus 3. Just call it a day at that, right? The other fraction that we had,
8 times,
8 times what?
8 times 2.
Oh, my fault. Whoops. Good catch, my fault. Getting tired. 16, that's 24. Yeah. Thank you for that. Appreciate it. Let me just scroll up real quick. So I got a 3x over, hold on one second, x plus 3, x plus 1, right? But what am I missing, right? I'm missing that x minus 3. But what I do to the bottom, I do to the top, right? X minus 3, just like that. So that being said, what do I have? Distribute the 3x. I have 3x squared minus 9x, right? All over, what's this? The x plus 3, x plus 1, x minus 3. These are the equivalent fractions. Hold on, I forgot a parentheses over here. All right, that's good. These are the equivalent fractions that they asked about. All right. I don't know if anybody wants to take a picture. Let me just make it a little bit smaller. Real quick. Just kind of get there. There we go. That might be kind of small. Y'all can see that? Let me see if I can hit it just one time if it get too big. Yeah, it's too big. Can't see everything. All right. All right, that being said, let me let y'all try. Go ahead, try that out. Yeah, that's it. So you have the two equivalent fractions right here. These two in blue. And you found the LCD, which was the x minus 3, x plus 1, x plus 3, and that's it. Yeah. And you can just type them in just like that. No pressure. So yeah, just wanna mind y'all that tutoring is open tomorrow. If you guys wanna go. You don't have to go in person, you can go online as well. Yeah, you could do Zoom as well. Yeah. Yeah, just make the appointment and then they'll email it to you. Okay? It has to be in person, yeah. But you don't have to do it like tomorrow, like whenever you got time. No, just get it to me before the final. That's a comma, yeah, yeah, yeah. Cause, so what we're doing in this exercise, we're just finding the LCD and we're rewriting the expression, but we're not actually adding or subtracting yet. We gonna get back to that though. So like basically what we're doing is we're transitioning from having the same denominator to having like different denominators. Yeah.
Oh, so it's the factoring.
Yeah. All right, let's take a look. All right, nothing crazy here, nothing crazy here. So I got 2 over x squared minus x minus 12. And I got 1 over x squared minus 16, right? So first thing I gotta do, let's factor both of these, right? So this is gonna become what? 2 over, help me out, what's this? This is x and x. I need 2 numbers that multiply to negative 12 and add up to negative 1. What are they? They have to multiply to negative 12, 2 numbers, and they have to add up to negative 1. Negative 4 and 3, right? Very good. How about the other one over here? This is x squared minus 16. Excellent. X plus 4, x minus 4. That's it, right? LCD then? What's that going to be? X minus 3, no. X plus 3. What else? Very good. Just like that. All right. Now that I have the LCD, whatever I'm missing, that's what I'm going to multiply this by. So I have x minus 4, x plus 3, but this is missing an x plus 4. So I'm going to multiply this by x plus 4. What do I do to the bottom, do to the top? Over here, I have x plus 4, x minus 4, but I'm missing an x plus 3, so multiply this by x plus 3. What I do to the bottom, I do to the top. All right? And after that, let's just simplify this down just a little bit. Distribute, pop, pop, pop. Right, so what do I have? I have 2x plus 8, God bless you, over LCD, x minus 4, x plus 3, x plus 4, comma, I have what? X plus 3 over x plus 3, x minus 4, x plus 4. Simple, 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 right? And that's it. Go ahead.
So how big is that?
Mhm.
Yeah, but that was-
No, it don't matter. Same old, same old. All right. So you just type that in. That's the answer in web work, and that's it. All right. Go ahead. It's whatever's missing, right? So the idea here is I want to turn each denominator, right, into the LCD, right? So in the first one, right, I had the x minus 4 and the x plus 3, but I was missing the x plus 4. So that's what I multiplied it by. And then in the second one, I had the x plus 4 and the x minus 4, but I was missing that x plus 3. That's why I multiplied that by. Yeah. So that's the idea. Right? So here's where I'm going with this. Here's where I'm going with this. So I want to be able to add or subtract rational expressions with different denominators. All right. So let's start off real basic right here, right? I have 3 over x minus 3 plus 2 over x minus 2. These denominators are different, right? So I have to get the same denominator. Help me out, somebody. What's the LCD here? Is there not 12? Give you a hint. What is it? Hmm? Mhm. What is it? All right, I literally just want y'all to just multiply the two denominators together. That's it. That's the LCD. X minus 3 times X minus 2. That's simple, right? After I find the LCD, you already know what's gonna happen, right? I'm gonna multiply this by X minus 2 to get the same denominator. But what I do to the bottom, gotta do to the top. X minus 2. I have the X minus 2 on the other rational expression, right? I'm gonna multiply that by the X minus 3 to get the same denominator. But what I do to the bottom, I do to the top. And that's it. That's it in a nutshell, right? So what do I have now? I have 3 times X minus 2 plus 2 times X minus 3, all divided by the LCD, which is X minus 3 times X minus 2. Distribute, you already know, and then combine like terms, right? So 3X minus 6 plus 2X minus 6, all divided by the same thing, X minus 3, X minus 2. Combine like terms, what do I have? 3 plus 2, 5X. Negative 6 minus 6, negative 12. Over X minus 3, X minus 2. No, what the heck? No common factor in between the 5X and the 12, so it's just this final answer right here. Yes, they could ask you about an excluded value. If they ask you about the excluded value, take the X minus 3 and the X minus 2, set that equal to 0. Exactly, right? So that would be our excluded value, right? It'll be X equal to 3 and 2. Those are my excluded values, if they ask you for that. If they don't ask you, then you're good. You just give them the answer and that's it. Questions on this? So we find the LCD. Sometimes it's easiest to just multiply the two denominators together, right? And then make the two denominators the same. What you do to the bottom, you do to the top, all right, for both. And then just add or subtract, and that's it. Okay. You guys try. I'll make it a little bit harder. Y'all got a plus and a minus. Go ahead. So basically just add these. Find the LCD, get the same denominator, bop, bop. Yeah. I'll make it a little bit smaller so you can see. That's it. I will be honest with you about something. This is true when it's numbers as well, right? Sometimes it might be really hard to find the LCD, Another method that does work that you could use is you could find a CD instead, right? Just a regular common denominator. So to find a common denominator, all you have to do is take the two denominators and multiply them together, and that's it. If you use this method though, right, in the end, you're gonna have to reduce the fraction that you get. It's the same thing with the numbers, right? If you find a common denominator, you're gonna have to reduce the final answer. Same thing here. But if you're comfortable with reducing, that might be the easier way to get through these problems. Find a common denominator and forget about the LCD. But if you can find the LCD, I think you should. Makes it a little bit easier. And on the test, whichever way you choose, you get full credit for it. As long as you give me the right answer, I'm down with whatever process you like better. Yeah. All right, let's take a look. So I got, hold up. See, I remember this time I got my pen. Yeah. So I got 2 over x minus 2 plus 5 over x plus 3, right? So now I want to find the LCD. Somebody tell me what's the LCD over here? X minus 2 and x plus 3. Very good. Right? That's the same way that I would have done it. Just multiply them two together, right? So I want to get both of these rational expressions to have the same denominator. This one has an x minus 2, but it's missing the x plus 3. So I'm going to multiply it by that. But what I do to the bottom, I got to do to the top. So I'm going to multiply this by x plus 3. For the second rational expression over here, right? I have the x plus 3 on the denominator, but I'm missing the x minus 2. All right, so I'm gonna multiply this by x minus 2. But what I do to the bottom, I gotta do to the top. Right, multiply this by x minus 2. Then after that, straightforward, right? I'm just gonna distribute, combine like terms, all that good stuff. Right? So let's distribute the 2, distribute the 5. What do I have? I have 2x plus 6 plus 5x minus 10, all divided by that same denominator, x minus 2, x plus 3. Let's combine like terms. 2 plus 5, I think that's like what, 7? 7x, let me cross those out. And then minus 4, good. 6 plus negative 10 is negative, right? 6 plus negative 10 is negative 4, all divided by x minus 2, x plus 3, right? Let me just close parentheses there. That's my answer right there. Yeah, that's it. That's the end of it, right? If they ask you in your homework for excluded values, real quick, tell me what that would be. All right. Right. So how you get those, just set the denominator equal to 0, right? So I'm talking about x minus 2, x plus 3 equals 0, and you already know, solve for x individually, right? All that good stuff. And that's how I get the 2 and the negative 3. And that's it. Okay. Questions on this? Sure. Give me 1 second. Just, nope, that's not it. Try that one more time. Load. Let me get one more. All right, I think that's it. I know I like to highlight, so let me just get one of these going right here. That's my answer right there. It's my excluded values right here. All right. So if there's no questions, let me let y'all try. Get back to 100. Blah, blah, blah. Real quick, let me just give y'all some procedures real quick before we continue. So a little how-to. So how to add or subtract rational expressions. Step one, determine if the expression has a common denominator. If yes, go to step two. If it doesn't have a common denominator, rewrite each rational expression with the LCD. Find the LCD, rewrite the rational expression as an equivalent rational expression with the LCD, then add or subtract the rational expressions and simplify if possible. That's it. All right. That's our procedure of how we answer these questions. Let's try another one. So I have 8 over x squared minus 2x minus 3 plus 3x over x squared plus 4x plus 3. First thing I should do here is what? Before that,
You get that out, but,
yes. So how do I do that?
okay.
Not multiply. No. Starts with an F.
Right.
Factor. That's it, right? So let's factor this. So I have 8. Hold up. I need a pen. It always happens. All right. So let's factor this, right? I have x squared minus 2x minus 3. Help me out with the factor here. This is x, this is x. I need two numbers that multiply to -3 and add up to -2. What are they? Two numbers that multiply to give me -3, and when I add them together will give me a -2. What are they? 3 and 1, okay. -3 and +1. Very good, very good. All right, keep that plus sign going. On the other side, I have the 3x up top, right? But I want to factor the denominator. So what do I have? This is going to be x and x. I need two numbers that multiply to 3. And when I add them up together, will give me a +4. What are they? 3 and 1, right? So +3 plus 1, right? And then that's it, right? Oh, Lord. Here we go. Don't freeze. Come on. All right. So help me out, right? LCD. What's that going to be here? I heard x plus 3. What else?
X,
X plus 1. What else?
X minus 2.
X minus 3. Good. Any questions on the LCD? We good? Good? All right. So now I'm looking at each one of these denominators individually, right? I'm looking at the first one with the 8 on top, right? So I have x minus 3 and x plus 1. But I'm missing the x plus 3. So I'm going to multiply this by an x plus 3. But what I do to the bottom, I got to do to the top. X plus 3. I'm looking at the second rational expression now, the one with the 3x. I have an x plus 3 and I have an x plus 1, but I'm missing an x minus 3, right? So I'm going to multiply this by x minus 3. But what I do to the bottom, I got to do to the top. And then after that, straightforward, right? Straightforward. Let me switch this up. I'm going to go purple real quick, right? So we're just going to distribute. So what do I have? I have 8x plus, what's that, 24? Good. Plus 3x times x, what's that? 3x squared minus 9x, something like that, all over the LCD, right? That's the x plus 3 times the x plus 1 times the x minus 3, right? Let's combine like terms, right? Combine like terms. So when I combine like terms here, right, I'm going to have what? The 3x squared And then now 8x plus negative 9x is what? Negative x, very good. Done with that. And then I have the 24, right? So plus 24. After that, this is all over the same LCD. Nothing's changed, right? X plus 3, x plus 1, x minus 3. Now, what I want to do here, right, is I want to factor the numerator. Factor the numerator, right? So let's take a look what this is going to be. All right. Do I want to do? Nah, let me do blue. Nah, I'm gonna go back to black. All right. So factor the numerator. Right? This is gonna be what? 3x here, x here. Two numbers that multiply to positive 24 but add up to negative 1. Yeesh. What is that gonna be? I'm thinking. Mm-hmm. Might not be able to do this one. I'm thinking. We could do the AC method. AC method not gonna help us much though, but let's see. A times C. Yeah, 3 times 24. What's 3 times 24? No, 3 times 24. Yeah. That's 48, 72. And then we need a B, which is negative 1. So two numbers that multiply to 72 and add up to negative 1. Yeesh. I don't even think that could work. Just looking at it. But they're not gonna add up to negative 1 though. But I can't subtract them because it's a positive 72. That's the issue. Yeah, so remember when the C term is positive, both of them have to be negative or both of them have to be positive. So in this case, it's not gonna work. So this is my answer right here. And that's it. It be like that sometimes. All right. So when you can't factor the top, don't assume that you can't factor the top. Actually, try it. Do it. All right. When you can't factor the top, that's it. All right. I'm not saying that every question is going to be like that, but in case you encounter a question like that, you know what's going on, right? So, all right, I'm gonna be honest with you, Russell, right? So, like, it can be factored. We just haven't learned how to factor that yet. Later on in the class, we will. All right? If it can't be factored by the AC method, just leave it. All right? But we
With the method that you're gonna teach later on.
factor everything, every single thing. But we working up to that though. We working up to that. By next test, this is be nothing to you. Not this test coming, the one after. Mhm. Absolutely. Let's hit one of these. Yeah, that's it. All right, you're welcome. You guys try. So the first thing that we want to do, right? We want to factor those, right? And then find the LCD. What you do to the bottom, do to the top, combine like terms, boom, that's it. Nobody else is copying. Just gonna do one of these real quick. So we all gonna go see the fireworks on Thursday? I normally watch it on TV, to be honest. I never seen it in person. I imagine though, if you go in person, you don't hear the music, so. I'm in Manhattan. I don't remember if it's the east side or the west side. One of the sides of Manhattan, they have the fireworks. I'm sure this weekend, everybody's gonna have their own personal fireworks going off in your neighborhood. All right. Matter of fact, I think it was last week, I was leaving BCC at one point, right? And somebody was shooting them like right off that, you know, that little park across the street where they got the deli, like they were shooting them off right over there. 3 days? Oh, man.
Right, so,
Yeah. At nighttime, yeah, yeah, yeah.
They already started.
Yeah. A couple days before and a couple days after, right? Yeah. That's the day, yeah. Yeah.
I used to be having mad fireworks and just trying to get off.
Yeah. But you know what's interesting though? Like, I don't know, I feel like in the rain, I don't hear it as much. But like the professional people, like the ones that do it in Manhattan, like rain or shine, they gonna shoot that off, you know? All right, let's take a look. So remember, I want to factor this, right? So this is gonna be, hold on, I need a pen first. All right, so this is gonna be what? This is gonna be M times M. Two numbers that multiply to -2 but add up to -1. I'm thinking -2 and +1, right? And over here, I'm gonna have 5M. Then I need two numbers that multiply to +2 but add up to +3. Right, so I'm thinking about +2 and +1, right? LCD over here. I'm thinking M-2, M+2, M+1. Everybody agrees? All right. So then you already know what's gonna happen next. All right, I have the M-2, M+1, but I'm missing what? I'm missing an M+2. I'll multiply this by M+2. I do to the bottom, I do to the top, M+2. I have M+2, M+1. I'm missing an M-2, so I'm gonna multiply this by M-2. What I do to the bottom, I do to the top, -2. So now what do I have? Let's take a look. I have 1 times M+2 plus 5M times M-2 all over the LCD, right? That's the M-2, M+2, M+1, right? Which one? Oh, no, I didn't do that part yet. Yeah, that's the next step. Yeah. So then now I want to distribute, right? Yeah. So now I got the M+2 plus the 5M² minus 10M, right? And then all of that over the LCD. M minus two, M plus two, M plus one. Wow. That was mad work too, you know that? M minus two, M plus two, M plus one. I could imagine on the recording, that's like when the DJ is like, bring it right back, start it over. All right, so then now let's combine like terms. I have 5 M squared minus 9M plus 2. All I'm doing is I'm combining like terms up here. All right. And then of course, that's all over the same LCD. All right. So I have what? M minus 2, M plus 2, M plus 1. Right. Now I'm going to attempt to factor this. Right. So let's see, we're going to do A times C. That's going to be what? 5 times 2, which is 10. And then I want B term is -9. So I need two numbers that multiply to 10. When I add them together, will give me a -9. What are they? -10 and 1? No. Because look, -10 times -1, yes, that is 10. But -10 plus -1, that's -11. All right. So long story short, we can't do it. So this is my answer right here. Right? Yeah, sure. So again, don't assume that you can't factor the numerator. All right. But just know that there might be a possibility that you can't factor it. Oh, this was a lot of writing. There you go. Yikes, that's small. My apologies to those in the back. All right, we good? Awesome. Toot, toot, toot. Woo. All right, let's try a subtraction problem real quick, and then we could call it at that. Unless y'all want to stay for a couple more minutes to do a couple more examples, we could do it that way too. But real quick, subtraction over here, right? First thing I'm gonna do here, factor, same thing, right? I'm gonna factor this. That's my first step. So I have 8y over, this is gonna be what? Y minus 4, y plus 4, right? Minus 4 over y minus 4. LCD. This is what? Y minus 4 times y plus 4. That's my LCD, right? So all I need to do is multiply this second one by y plus 4. And that's it. They have the same denominator. What I do to the bottom, I gotta do to the top. Y plus 4. All right, check this out. Watch the difference. Watch the difference right here. Please scroll down. Good, good. I have 8y minus 4, open parentheses, y plus 4. Of course, all over the LCD, which is y minus 4, y plus 4. What am I going to do here? Distribute, right? Distribute. But what am I distributing? The -4, right? So now what do I have? I have 8y minus 4y minus 16, right? All over the y minus 4, y plus 4. Combine like terms, what do I have? I have 4y minus 16 over y minus 4, y plus 4. Now, greatest common factor in the numerator, what's that gonna be? It's gonna be 4, right? So what am I left with? Y minus 4 over y minus 4 times y plus 4. I have a common factor in the top and the bottom. Cross them out. Final answer here. 4 over y plus 4. And that's that. Questions on that? Yep. The trick in this one is that I wanted to show you that when I'm distributing the numerator of that other question, right? I'm taking the negative with me. That's what I wanted you guys to see. 1 second. Is that it? Yeah, that's good. All right, go ahead. Y'all can take your pictures. So yeah, I just wanted to show you that second step right there. I'm taking the negative with me. So it's not just the 4 I'm distributing the negative 4. And then right after you distribute that negative, you're back to addition, right? Combine like terms, factor if possible, simplify. That's it. Right? And we went over the excluded values, so we good to go. That's about it. I mean, if y'all would let me entertain y'all with another problem, I'll gladly do another problem. But that's about it for the homework. Y'all have all the tricks. All right. Good. So it's every day, Monday through Saturday. For for me, so Monday, Wednesday, and Saturday. Not my choice, it just happened that way. Yeah, I was gonna say. So Monday is 12 to 3, Wednesday is 1 to 5, and Saturday is all day 12 to 6. So you probably got the right answer, but the thing that they want the GCF first. So put like the X first and then do the other stuff. Oh, what's it called? The X minus 3. CPH room 303. And then so the whole idea here. Oh, skip this. Happy New. So the whole idea here is that you wanted to put the GCF first, and then hey, yeah. Let's take a look.
You can tell me how to make an appointment for
Which one you want to
yeah.
do? In person or online?
Online.
Online. So what you do, you come up here where it says schedules, right? Schedules, and then you have 2 choices. So this is in person. Oh, I see, man. This is in person and this is online, right? So if you want to do online, you just click on the online.
All right.
And then
Okay.
go down. Okay. So you could just choose any one of these white spots, just click,
All right.
and then you can make an appointment.
All right.
Everybody can help you. So anybody you want. Today passed, so that's why that's there. But the whites are all open times. Right? So you just click when you can make. I see. Click there, make the appointment. They're gonna send you a confirmation email. In the confirmation email has the link
All
to
right.
Tutor Online.
All right.
So in person,
Yeah.
just for link,
Yeah, same thing in person, but
you don't have the link.
no, there's no link for in
Oh.
person. You just go. Right? So this is the in person. You can just make an appointment, all the whites are open, you know, just click there,
just
make the
put-
appointment, and then just come CPH 303.
Oh,
Yeah. I mean, if you forget to do the appointment in person, you can just walk in. They prefer if you could, you know, make the appointment and then done. Yeah, yeah.
All right,
You're
thank you.
welcome, you're
No,
welcome.
I don't see anything on this, so this is the next thing where we want to have, you're gonna be
Yeah.
on or, so,
Yeah.
you're gonna be tomorrow
Or the test?
Yeah.
The test is probably gonna be like, I'm debating between Monday and Tuesday.
All right.
I'll tell you guys something by Wednesday.
All right.
Yeah.
Thank you.
Alright.
Everyone-
How you been, man?
They were getting this yesterday.
I got you.
Yeah. Then
They're sorry. Sorry. Sorry.
My friend is about after what
Yeah, just watch the recording, knock out the homework, and you get to.
Yeah.
I didn't update the homework as yet. I'm gonna do that right
All right.
Yeah, Chris Marvin Jones.
Why was that?
now. Yeah, definitely.
Yeah.
Okay, come in early one day and then we can do the test. like- Yeah. So you have x plus 2, but it's not x plus 2 for the factor of the top.
X minus 2?
Yeah. Are you still copying from the? Oh, are you still copying from?
No, I took,
You got it. All right. All right.
yeah, I got it correct now.
Awesome. You know what? Like just for the recording, I feel like I want to do one more question.
So Chris, could you
And
send
then-
me
and then
email
y'all-
about the tutoring thing? I think I'm gonna do this.
Yeah. Yeah, I got you.
Yeah, 68.
In the look at the announcement. The next announcement that I made, I'm gonna put the link in there. You can just click it and just go ahead and do it. Yeah.
So I can do it online?
Yeah. Whatever's easier for you. Yeah. Not for the test though, only for the homework and stuff.
For the
Yeah.
test. I can do it in person?
Yeah, I have to be on person, yeah.
Alright, so I'm just gonna put those
But you got time though, you know, like no pressure to like, you know, no deadline with it. Just get it to me before the final.
Gotcha. So,
Yeah.
can you help me with this one?
Yeah. Hold on. Let me just do one more question real quick for the recording.
I'm
And
doing
then
great.
I got you. All right, so I just want to do one last question to those who are watching the recording and those who decide to stay a little bit later. So this is a subtraction question right here. I have negative 3n minus 9 over n squared plus n minus 6 minus n plus 3 over 2 minus n, right? First thing I want to do here before I start doing anything is I want to factor, right? Not really concerned with the numerator. I'm more so concerned with the denominator and factoring with this, right? Because I want the denominators to be the same. So I have 3, hold up, let me get a pen. Always make this mistake. All right, so I have negative 3n minus 9, right? And I'm gonna factor this denominator. So this is gonna be what? This is gonna be n. Hold up, I gotta practice writing my n's. So this is gonna be n and n right here. Two numbers that multiply to negative 6 and add up to positive 1. I'm thinking of, right? Plus 3 and like what? Negative 2, right? That should work. And then over here, I have what? I have n plus 3 over this 2 minus n, right? Now, remember we had that conversation, right, earlier in the class about the opposites, right? So first thing I want to do here before I even start talking LCD, right? I want to get this denominator look similar. So I'm going to multiply this by negative 1. But remember, what I do to the bottom, I got to do to the top, right? So when I'm multiplying these out, right, this is going to distribute like this. This is going to distribute like this, right? Let's look at what I have right now. I have now negative 3n minus 9 over the n plus 3 times the n minus 2 minus, so now I have negative n minus 3, that's up top, over, open parentheses, the n minus 2. All right? So now, when we look at what the LCD is, LCD, is n plus 3 times n minus 2, I'm only missing the n plus 3 over here. But what I do to the bottom, I gotta do to the top. N plus 3, boom, right? And then you already know what's gonna happen after this, right? I'm just gonna distribute, combine like terms, all that good stuff, right? So let's take a look at that. Let's take a look at that, right? So I have the negative 3n minus 9 over here. It's a little bit complicated over here, right? First thing I want to do, I want to distribute these, right? We're gonna FOIL these over here. Boom, 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 right? So I'm gonna keep the minus, open parentheses. Negative n times n is negative n squared. Negative n times 3 is gonna be a negative 3n. Negative 3 times n, that's a negative 3n. Negative 3 times positive 3 is gonna be a negative 9, all right? All divided by the LCD, which is what? N plus 3 times n minus 2. Now, the next step that I want to do before I distribute that negative, I want to combine like terms here, right? Combine like terms. So I have negative 3n minus 9 minus, open parentheses. Oh, my fault. I meant to say that I want to combine the like terms in the parentheses, right? In the parentheses in particular. So this is the negative n squared minus 6n minus 9. That's it. All divided by the LCD, which is the n plus 3 times the n minus 2. After that, it's real straightforward, right? I'm going to distribute that negative that's right there. Boom, 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 right? And then I'm going to just combine the like terms. So what do I have now? I have negative 3n minus 9. A negative times a negative is a positive, n squared. A negative times a negative is a positive, plus 6n. And a negative times a negative is a positive, plus 9. All divided by LCD, n plus 3, n minus 2. Combining like terms, here's what I get. I'm going to have n squared. Cross that out. Negative 3n plus 6n is going to be a positive 3n. Cross that out. And then negative 9 plus 9, that's 0, so that's going to cross out. All over n plus 3 times n minus 2. Now I'm going to factor, greatest common factor, the numerator. Let me just make this a little bit shorter. I'm going to do the greatest common factor in the numerator here. That's going to give me what? N times n plus 3, all divided by n plus 3 over n minus 2. I notice that they have a common factor, the n plus 3, so I'm going to cancel that out. My final answer for this is n divided by n minus 2. And then that's it. All right. So that's kind of like combining all the stuff that we did today in one question. Right? A little bit tougher, but I wanted you guys to have that at least have it on the recording, you know, so you could take a look at it when you look back at it. I'm just gonna zoom out a little bit. I don't know if anybody want to take a picture or y'all good. Wrote it down? All right, good, good. Or maybe just for online, if anybody wants to take a look at the whole thing together. 1 second. Oh, we're freezing a little bit over here. 1 second. Okay. Almost 1 second. Let me just get this one more time. We get it one more time after that. Oh, that's not it. Let me get one more time. All right, I think, oh. All right, we're good with that. Good with that. So now you can all see everything right there. All right, so 6, good, 7. Perfect.
But then what do I put the?
Yeah, so rewrite it. So it's going to be 2x squared plus 3xy plus 2xy plus, is that 4? It's 3. And, you know, group them.
So I don't understand that.
Real quick, you guys done with the board? Yeah. All right, so we're gonna call it at that. Have a good night, everybody.